So in this example, we're going to take a look at putting together an X-bar chart where we don't know what the standard deviation of the process is. And so what we're going to do from there is we're going to use the table. So we're looking Super Cola bottle soft drinks labeled net weight 12 ounces. Indeed, an overall process average of 12 ounces has been found by taking 10 samples, in which each sample contains 5 bottles. So the operations management team wants to determine the upper and lower control limits for the average in this process. So if we go over here and we look at the data, as we can see, we do not have that process standard deviation, but what we do have is we have the range of our samples. So they've taken 10 samples, and each sample set is 5 samples, and they have here the heaviest and the lightest of that set. So what we're going to do is we're going to put together that upper and lower control limit based on our table. So in the last one, in 6.1, we had done the mean plus or minus our standard deviation times the z-value divided by the square root of the sample size. And so in this time, what we're going to do is we're actually going to use our table. And our table is table 6.1 in our textbook. And so the way that we calculate out the upper and lower control limit in this case is going to be the mean plus or minus A2, and A2 is that constant from table 6.1, and that constant is meant to be set up from this kind of situation times the average range. And so the average range is nothing more than the heaviest sample minus the lightest sample. And so we're going to do that right now. And now, since I'm just looking at pure values and I don't really care what the positive or negative sign here is, what we'll do is we'll just use the absolute function, and that's going to be the absolute value of the difference between the two. And that way it's just going to tell us purely how far is it from one to the other, and we'll have no negative sign. So I subtract the two values from each other, I take the absolute value of it, so that gives me a range for this first sample of 0.22. And we'll just drag this down. And so what these are now, these are the ranges, highest to lowest, from our samples. So it kind of gives us an idea of how much variation that we're going to have within the set that we're taking up. And so now what we need is we will need the average of the range. So let's sorry about that. Let's throw together some range names just so you can go back if you're reviewing this and it'll be a little bit easier to look for. So we'll create from selection, we'll do the left column, and then I do want to arrange this one here, and so top row. And so we'll come over here and we'll just type in range names. Oops, I hit the capital there. Range names, Control B to bold that, and using formula paste list, and there we go. So there's all the range names that we're going to use. Okay, so average range. So what this is this is going to be the average of all of our ranges. Let's start to type in RNGE. Oops, I can actually highlight the right one, hit tab to fill that in. So we take the average of our range, and that's 0.25. We can put ounces here because that's what it is. We can come up here and put our ounces in so we know what we're talking about. Okay, and so now what we need to do is we need to go look at that table table 6.1 to find out what that constant A2 is. And so what that's going to be based on is it's going to be based on the sample size. And this is where things get a little bit confusing because the sample size is not 10. We've taken 10 samples. The sample size is 5. So we have 10 samples and each sample is size 5. And so anytime that we're looking at any of this stuff where we're dealing with the sample size, we're talking about how many instances within the sample, how many instances we're querying for our set. So in this case, since we pull 5, our sample size is 5. And so from table 6.1, A2 is 0.577. Okay, and from there, now that we've got this information, it's really easy. So now we just do the mean value, and then we plus or minus the A2 times the average range. Now the mean value we already had from the problem. They told us that back in here, the overall process average is 12 ounces. So we know that already. We didn't have to calculate anything. And we have our range there, so let's go put this together. And so this is going to be the mean. And then we will add to that A2, and then we'll multiply that by the average range. And so that gives us an upper control limit of 12.14425, and our lower control limit will do the same thing, mean, except this time it's minus A2 times our average range. And so we have a lower control limit of 11.85 ounces. And so what we've done is we've put together this upper and lower control limit based on the data that we have. Since we don't have that process standard deviation, we're able to use the table and our ranges and put it together this way. So our process should run on the average from 11.85 ounces to 12.144 ounces. And if we actually wanted to draw the control chart, we'd do it in the same way as the last problem. Since we don't actually have the average of those sample sets, can't really plot it out correctly. I mean, we could average the upper and the lower and it'll give us pretty close, but in this case I really just wanted to focus on putting together those upper and lower control limits. With that, if there's any questions, let me know. Otherwise, I'll see you in the next video.